All right, so let's talk thunderstorms. Today, I want to go through thunderstorms. They're very cool to talk about. Lots of great examples out there, of course. They are very relevant to us because they happen all the time. Here in the central US, we get a lot of them, and the ingredients are right. So, we're going to talk about how they're defined, their ingredients. We'll look at how they evolve from beginning to end, look at how they're classified. There are different types out there, where they occur, and then we'll look at some of the hazards associated, such as hail and lightning and wind. So here we go with thunderstorms. Cumulonimbus clouds are the ones that produce thunderstorms, creating rain, lightning, and thunder. Really, only 10% of thunderstorms are considered severe, and you actually need another and extra ingredient to make that. We'll talk about that in a second. But severe thunderstorms are defined as those that have tornadoes, strong winds, which are almost 60 miles an hour or greater, and then hail greater than about an inch. And this is a picture of a big supercell thunderstorm in South Dakota. Thunderstorms require three ingredients, and that would be moisture, which is, of course, the rapidly rising moist air. That air comes for us from the Gulf of Mexico. That's the air mass that comes, that maritime tropical air mass from the Gulf of Mexico. We have instability, which is a relatively cool surrounding upper atmosphere. So as the warm, moist air cools and condenses, it remains warmer than that surrounding atmosphere. So the rising ability. And then you got to get that warm, moist air rising upward. The most common way is to warm it all day so that by the afternoon, it is nice and warm and can be lifted up, but also advancing cold fronts or even wafting the air up a mountainside can do this. And then those severe thunderstorms require an additional ingredient, and this is shear, which is organization of winds in the upper levels. So wind shear is kind of how the winds increase in speed as you get higher and higher in the atmosphere. And what that does is help tilt the storm forward and organize it so that the thunderstorm doesn't get cut off from its fuel, which is that rising warm moist air. Another beautiful picture of a thunderstorm with lightning here uh, from that same area. Let's talk evolution. In general, thunderstorms go through three stages of evolution that we're going to outline here today. The cumulus stage, which is where they begin to develop, the mature stage, which is the dangerous weather time, and the dissipating stage when they rain out and come to an end. So let's talk through these. The cumulus stage is where we begin the warm, moist air rising. As the air rises, we call that the updraft. And of course, air is usually lifted, as we talked earlier, by daytime heating, but also cold fronts and topographic effects can lift up that air. When the air begins to rise, it cools. It's away from the heat source of the earth, and cooling, of course, causes condensation. However, we also talked about how when the air expands, it also cools through adiabatic cooling. This is how clouds form. And of course, when condensation occurs, it releases heat, which creates buoyancy in that pocket of air, which makes it rise even more. So this amplifies the updraft. In the higher parts of the cloud, not only does air condense, but the water vapor deposits. It goes from water vapor directly to ice crystals in the cloud. So it creates these nice ice crystal-y clouds in the upper levels, but that actually releases a lot more heat. And so you get this process of warm, moist air rising upward, but it also creates a situation of buoyancy, creating very tall clouds called cumulonimbus clouds that we know of as thunderstorm clouds. So this is how it all operates. And here's a beautiful picture, a diagram of a cumulonimbus cloud. Note, first of all, the tilt of the storm. That's because of that upper level winds moving faster than the lower level winds. What that does is it throws the rain forward. The lightest rain falls forward and actually evaporates before it even gets to the ground. The light rain, then the heavy rain, the light hail, the heavy hail, and then where the warm, moist air enters the storm, it actually swirls upward to form the swirl in a thunderstorm is called a mesocyclone. And if that tightens into a spiral, you can form a tornado there. So this is a great diagram of how a thunderstorm cloud or a cumulonimbus cloud would operate. Whoops. Then we come to the matured stage of the thunderstorm where the first drop of rain reaches the ground. And at this point, you have rain falling at a great pace, and it's been much of it has been evaporating on the way down. That actually causes cooling. So you got this gush of rain, but you got this gush of cool air hitting the ground. The cool air hits the ground and wafts outward in front of the storm. And when that happens, you create what's called a gust front. If you've ever been standing outside right before a large thunderstorm, you could feel the temperature get really cool all of a sudden and the winds start. That's the gust front of the thunderstorm. That's the evaporative cooled air hitting the ground and gushing forward, and you feeling that. The mature stage is the most hazardous stage of the thunderstorm because this is where you have all the high winds, the downdrafts that we just talked about, heavy rain, lightning, and thunder, and then possible hail and tornadoes, depending on how strong the storm is and how much warm, moist air is feeding it. The dissipating stage of the thunderstorm then is the one that is where the downdraft becomes so large that the cooled air that's hitting the ground wafts not only forward but backward and chokes off the warm, moist air feeding the storm. At that point, everything just rains out and the thunderstorm dies. It dissipates. So those are the stages of the thunderstorm. Let's talk classification. Thunderstorms basically have an unorganized form, and then they can be quasi-organized, which means kind of they're starting to develop or maybe starting to dissipate. And then you have your full-on organized thunderstorms, either in linear fashion or in cellular fashion. We'll talk about each of these here. Unorganized thunderstorms come in the single cell variety, which is just kind of your sometimes called popcorn thunderstorms. They appear, they disappear within 15 minutes or so, only affect a short or small area. Pictured there with the arrow. Then you have your quasi-organized thunderstorms, and these are stronger and more organized, perhaps representing the evolving thunderstorm in its developing stage, or maybe as in its dissipating stage. But you can see two types of quasi-organized thunderstorms here: either the broken line of cells, which you see pictured here, or a cluster of cells, not necessarily in a line, but all the cells are not connected. These are stronger and more organized, and again, oftentimes represent developing thunderstorms. Then your thunderstorms develop into either organized linear or cellular. In this case, the organized linear are nice, sustained, well-organized thunderstorms. They have a very good fuel source of warm, moist air. They've got a constant forcing mechanism of perhaps a cold front or lots of daytime heating, maybe a dry line in the case of tornado formation, which we'll talk about a little bit later. But you can see pictured here squall lines where the thunderstorm cells are all connected and the heaviest cells are all connected. Or in the case of a very organized thunderstorm, you have what's called a bow echo. It looks like a medieval bow where you shoot arrows from, and it's kind of bowing outward in the center because of the strong frontal forcing pushing that storm forward at a great rate. And then you have your organized cellular thunderstorms, and these come in the variety of supercells. And you can see pictured here, massive supercell thunderstorm. This is the one that produced the F5 tornado in 1999 in Moore, Oklahoma. We'll talk about that one when we discuss tornadoes. But you can see that supercells have a sustained rotating updraft. Typically, they last for 30 minutes or longer. They produce severe thunderstorm activity, including high winds, hail, and tornadoes. Typically, when you see this on radar, you know you're in trouble, especially if you're in this area. Right here is what we call the inflow notch of a supercell thunderstorm. And this is where the warm, moist air is rotating up rapidly. It's rotating so strongly, in fact, that the rain is wrapping around the upward moving air. So it creates a wraparound here and the inflow notch of warm, moist here. And the storm just progresses very, very efficiently. You can see all the heaviest hail is typically nearest the updraft. Then the lighter hail, the heavy rain, the lighter rain gets thrown forward by those upper level winds. Thunderstorms typically occur in three particular zones in the U.S. The central U.S., of course, and that's the one we're in. Warm, moist air from the Gulf of Mexico wafts northward and sets over the land, and then cold fronts come from Canada. The Rocky Mountains funnel them down this way, and then the westerlies push them from west to east. And so this cold air plows constantly forward and gushes. And as it does, it plows up the warm, moist air that's available and creates clouds and storms. A second area of thunderstorm activity that we see is in Florida. And Florida is a different case. Florida has a peninsula sticking down into the water. And what that does is the peninsula typically heats up very rapidly during the daytime. Land heats up faster than water. And so as the land heats up, the air rises really fast above the peninsula, and so much so that it draws in warm, moist air from the Gulf and from the Atlantic. And then once that air gets there, it also gets pushed up forward or pushed upward. So you got this conveyor belt here produced by daytime heating of the peninsula. And so that daytime heating is called local convection. Local because it's over a small region, and convection because it's hot air rising. So you'll get thunderstorms every day about 3 o'clock in Florida in the summertime, especially in the month of August. It's like clockwork. And then lastly, you'll see this little maxima of thunderstorm right here. Thunderstorms occurring in central Colorado because of topographic lifting. You have the cool, moist Pacific air kind of coming in, and it makes its way across the regions of between Northern California and Oregon here. And it makes its way to Colorado. And when it hits Colorado, it ramps up the mountainsides, rains out all the material, all the moisture that was in it. Okay, so that's another area where we see a good deal of thunderstorm activity. When do thunderstorms most occur? Well, late afternoon, early evening. And the reason for this is because this is when the air is warmest and it has the most water vapor in it. You've been evaporating air all day long, water vapor all day long. And by the mid-afternoon, when the temperature is the warmest, this is when the air can hold the moisture. And so this is typically when you're going to see the most thunderstorm activity. So you can see this is a particular area in Texas showing when the thunderstorm wind events occur. And you can see just before dawn, or as the sun is just before rising, and then also, or when the sun is rising, and then also in the afternoon here, a maxima, basically from like 3 to 6 p.m. Most thunderstorms usually in our area occur in June. And this is when the land surface and the low troposphere are the warmest. You can see here the little band indicating the month of maximum thunderstorm occurrence from this particular study. Noting that it's in probably late June here. We note that a little bit further, it's July, and even further north, it's August. And then if you go further south, it goes into May here in Texas and Oklahoma. This is when most thunderstorms occur. In our area. This is kind of a good combination of warm, moist air beginning to waft into to our area, along with still you have that upper level air that's still relatively cooler because we're in June, we're not in July yet. And so you've got good, vigorous uplift of the air, which is why June you would see the most thunderstorm activity. Hail is, of course, a consequence of thunderstorms, and one of the main types of precipitation. Hail is basically layered ice balls dropped from thunderstorms. You can see pictures of what you would see in the layers here. Buoyant or moist air rises from the heated ground, as we would see typically in a thunderstorm. But what happens is the raindrops will start to fall from the sky. They get caught in the updraft and kick back up into the higher parts of the cloud. Because the updraft is so vigorous, it'll refreeze that air or that water droplet. And so it'll come down as a little piece of ice. It gets caught in the updraft again and goes up and freezes another layer. falls and gets kicked up and freezes another layer. And by the time it gets strong enough or heavy enough to fall, it's a real big deal. It's got lots of nice little layers, and it falls down. These are typical in the early thunderstorm season because, again, the upper levels air has to be pretty cold in order to get those water droplets to freeze. And you can see it can get as big as a grapefruit in size. That's pretty crazy. Hail doesn't do a lot of killing, but it does a lot of damage, of course, and costs lots of money, especially if you're talking about wiping out a field of crops or some things of the like. Lightning is a major hazard in a thunderstorm. I'm supposed to have lightning in this picture here. There we go. Lightning is the electrical discharge of basically static built up in the cloud. You have lots of frictional motion of all the little particulates in the air. They're moving and churning in the thunderstorm, moving up and down and all around. It creates a lot of static electricity. And lightning is essentially static electricity discharge from the top of the cloud to the bottom of the cloud, and from the cloud down to the ground. Electricity discharge. Some fun facts here. Lightning is about 5 times as hot as the surface of the sun. There's a lot of heat involved with electron transfer and that electrical transfer. Streaks usually average about 8 inches wide, and they're up to a mile long. And they can travel in speeds of 60,000 miles per second in several strokes within a few seconds. It's a powerful force of nature. The tops of clouds build up excess positive charge, balance or opposite the bottom of the cloud, which builds up negative charges. And those that distribution of charges in different areas causes the static electricity to discharge between the cloud and the ground. So you can see some different ways in which this happens here. Typically what happens is the electrons will start to reach down from the bottom of the cloud, and as they reach down, it'll start to build up positive charges that actually reach upward, and they connect about 50 meters off the ground. And when they connect, the return stroke happens, and all the charges rush through the connection to replace and balance. And the lightning takes a jagged path through the atmosphere because it takes kind of the path of least resistance through the atmosphere. So it'll start to, as the charges start to climb down from the cloud, they'll kind of go through the particulates, the particular air pockets that have particles that are connected enough for the lightning to kind of go through. So it's kind of interesting how it takes a little jagged path as it goes through. As the streamers reach up from the ground, they typically reach up from the highest places. So a tree as trees typically get struck, taller buildings that are not grounded with lightning rods, or even if they are grounded with lightning rods, the charges will reach up through that. If you are the tallest object in the area, the charge will begin to reach up through you, and your hair might do something like this. If your hair is doing something like this, do not stop and take a selfie. You're in imminent danger. You would assume the lightning crouch, and I'll show you what that looks like in just a second. This is an infamous picture. It was taken, I believe, I forget when it was taken, but these two people died after this picture was taken. So you don't want to do this. This is a serious business. Lightning is the main cause of forest fires. The most deaths from lightning occur outdoors, of course, especially on open fields and ball fields. So when you hear thunder, it's when you can be struck by lightning. And lightning often strikes planes. This is a picture of lightning bolt hitting a plane. Oftentimes, a lightning bolt will just travel around the outside cage of the plane, and very little damage will be done. And maybe some instrumentation, but other than that, it actually is okay. If you're in your car and your car gets struck by lightning, it's a myth that the tires will help you. They won't. The lightning will pass around the outside cage of your car, through the tires and into the ground, and actually you will be fine. So if lightning strikes your car, it's kind of, you're more safer than in other places. Just don't have your arm hanging out the window. Lightning can strike up to 16 kilometers from a thundercloud. Wherever you you can hear thunder. You can be struck by lightning. So when you do so, just get indoors or under a shelter, um, a low place, or in a car. Uh, safest place might, or of course, the safest place is indoors, but cars are okay. If you're out in the open and you have nothing to do, you will assume the lightning crouch. And here's some funny uh, things I found when you need to be safe with around lightning. It says, see a flash, dash inside. When thunder roars, go indoors. Don't blunder when you hear thunder. Don't be lame, end the game. And here's the lightning crouch I was referring to. This poor guy maybe started to feel his hair rise up, so he dropped his golf club and assumed a lightning crouch. This is where you crouch down, your elbows are touching your knees. If you get struck by lightning, then the lightning will likely pass through your arms and the bottoms of your legs, tops of your arms and bottom of your legs, and enter the ground through your feet. So this is kind of the best way to kind of have the lightning go through without doing serious damage to your interior. If you have the lightning pass through your organs, obviously it can really roast them and cause them to burst. So this is a gruesome part of the death by lightning bolt. So this is your best bet. Most lightning deaths occur in July, and this is because this is when most people are kind of outdoors during lightning, or during thunderstorms, etc. Overall, in the U.S., on average, it's July. This is a lightning density map showing the most flashes occurring in Florida and in the southern parts along the Gulf Coast there, typically where you'd see a lot of thunderstorm activity or more thunderstorm activity than usual. So Florida has the most density, and this is a worldwide map showing the density of lightning in Central Africa here, and in some of the tropical areas is where you would expect to see it. Thunder is the discharge of a lightning bolt and heating the air. The air molecules expand at a rate that's faster than the speed of sound, so you cause a sonic boom. This is thunder. And lastly, wind is the last hazard. Violent downdrafts of air are called microbursts. This is where the air gushes downward, hits the ground, and wafts outward. This causes most danger to airplanes, because when you're taking off or landing, this is when you can have the most danger, and it causes crashes, which it has in the past. The last lightning hazard, or sorry, the last thunderstorm hazard would be a derecho. When the microbursts hit the ground, they waft forward. And if you get a fast enough propagating thunderstorm, this is like hurricane force winds. There are several examples of derechos coming from bow echo thunderstorms that have created lots of damage and deaths. Here's one such in 1998. But you can get, like I said, category 1, category 2 hurricane winds and cause lots of damage and kill people. So that, ladies and gentlemen, is thunderstorms.